This question asks, rank the following amines from least basic on the left to most basic on the right. So in order to answer this question, we have to think about what does it mean to be basic or not basic? And typically, basicity is going to mirror nucleophilicity. And so we're looking for a concentration of electron density. If you think back to kind of some qualitative methods we've talked about for assessing the strength of a base, we use Cario. So C for charge, A for atom, R for resonance, I for induction, O for orbital. If we look at these molecules, the strongest nucleophile, or sorry, the strongest base in this case, is going to be the lone pair that is on the nitrogen atom. Nitrogen is less electronegative than oxygen, and so that's why it's going to be the strongest, most basic atom in each case. If we take a look at the OH group, that's kind of where that big comparison is coming from. So N is going to be less able to stabilize electron density. So that's why we focus in on the nitrogen in each molecule. And then we want to think about resonance. So 3 out of these 4 molecules will have resonance. You can draw the resonance contributor like this in each case, where you can push the electron density into the aromatic ring. Only molecule 3 has no resonance. And that's important because that means that all of the electron density is just concentrated on that one nitrogen atom. So of all of the molecules, this is the one that's going to be the least stable. So say least stable. And the less stable it is, the more reactive it is. So that means it's going to be a stronger base. So least stable, strongest base. The other 3 molecules, we really have to focus in on the functional groups that are present on the ring. All of the functional groups are in the para position. And that's also significant because in the ortho or para position, the functional groups can play a role in the resonance. If they were in the meta position, then they wouldn't. So in this position, we can think about what other resonance contributors could we draw. In a case like the acetophenone or the acetyl group here, we could move the electron density up onto the oxygen atom, which would make a positive charge here. And so the aromatic ring would be able to accept electron density, or sorry, donate electron density out onto that functional group. So we could push the electron density through the molecule and onto that functional group. So that further stabilizes the molecule. We can do the same thing with the nitro group over here. And that will also further stabilize the amine in option 4. So the question here is basically, which group is a better, which group is going to pull the electron density stronger. So this is really helpful in thinking about kind of directing effects. Like way back when we started to think about, how do these different constituents impact directing effects? And nitro groups were considered strong electron withdrawing groups. And the acetyl group was considered a moderate electron withdrawing group. So we can use that here to kind of tell which of these 2 molecules is going to be more stable overall. So the nitro group, which is a strong electron withdrawing group, is going to be the most stable. So the most stable is going to equal the weakest base. Lastly, let's take a look at the lone pair on the oxygen atom. Instead of pulling electron density away, it donates electron density in. And so because of that, that's going to be destabilizing. We also know that the hydroxyl group is a strong electron donating group. So in this instance, having the electron donating group there destabilizes or kind of concentrates or helps to concentrate the electron density further up by the nitrogen. And so that's going to make it stronger as a base. So if we're thinking about how to categorize these from least basic to most basic we already decided was going to be 3. Least basic we decided was going to be 4. So next we have 1. 1 is going to be less basic than 2 because of the electron-withdrawing group that's present that helps to stabilize the amine electron density. And then 2 is going to be next. So 1, 2, and 4 all have resonance, and that's why they're kind of underneath of or less basic than 3, which has no resonance. So this question brings a lot of different ideas together, but it's really just an acid-base question, and it's really going back to what is resonance and what is, what makes a base strong or weak. So tying it all together here and applying it to amines. So with that knowledge, the answer that we're looking for is answer choice E. It matches what we drew up on the slide.